Hi guys, welcome back. We're going to start talking about systems of equations today, okay? And we're going to start doing it by graphing. There's actually several different ways to do it, but we will start with graphing. Okay? All right. So a system of linear equations is a set of two or more linear equations containing two or more variables. So basically we have two equations with two variables. And our goal is to find a solution that works for both of the equations. So the first kind of step that we take is I'm going to give you a system of equations and an ordered pair, and we have to decide if it's a solution to the system. So a system a lot of times will have these fancy brackets around them to show that those two equations are together. And what I'm going to do is I'm going to plug in the point to the top one and the bottom one and see if it works for both. Okay, so x is 4, so I'm going to have 4 plus 2 times y, which is 1, equals 6. Well, 2 times 1 is 2. And conveniently, 4 plus 2 does equal 6. So that checks out. I'm going to do it again with this problem. So I'm going to have 4 minus 1 equals 3, which does in fact work because 3 equals 3. So we would say yes, it is a solution. Okay. Why don't you go ahead and try the second one for me? And again, we usually have that fancy bracket there. Okay, it's just kind of hard to draw on a Google Doc. And we're going to plug it into the top and bottom one. So I'm going to have 2 times negative 1 plus 5 times 2 equals 8. Well, 2 times negative 1 is negative 2. 5 times 2 is 10. And conveniently, negative 2 plus 8 does equal 8. I'm sorry, negative 2 plus 10 equals 8. So it checks out for that one. Let's make sure it checks out for this one. So I'll have 3 times negative 1 minus 2 times 2 equals 5. Well, this gives me negative 3 minus 4 equals 5. So I get negative 7 equals 5, which is not a true statement. So this is not a solution. Okay. If we had plugged it into this top one and it didn't work right away, I wouldn't even have to plug it into the bottom one, because if it doesn't work for one, it doesn't work for both. Okay. So you can get some less work in that way if that works out. Okay. The next thing we're going to do is I'm going to give you a system and we're going to try and find the solution by graphing them. Okay, so we're going to graph both of them on the exact same graph. You might want two different colors here if that helps you. So I'm going to graph this first one in blue, and it's already in y equals mx plus b form. So my y-intercept is 3 and my slope is 1. So I'm going to go up 1 over 1. And notice I'm going to add a couple extra points in either direction. That's going to help me keep my line nice and straight and help just in case if I don't have a perfectly straight line to see where the two lines intersect. I'm going to go ahead and do this one in orange. My y-intercept is negative 1 and my slope is down 1 over 1 since it's negative 1. And we can already kind of see where they intersect, but I just did my extra points just out of habit. Okay. So I can see right here, this is where we're intersecting, and we're intersecting at a nice pretty point for this one. So that would be the point 1, comma, negative 2. So my answer here is negative 1, comma, 2. Now I can check myself with that. I can plug those back in here. So if I do that, I would have 2 equals 1 minus 3. I'm sorry, negative 1 minus 3, which in fact does not equal out, does it? I apologize. This should be, conveniently, I flipped my negative signs, positive 1, negative 2. So again, because I checked my work, I realized I had the wrong answer. So if I plug this in correctly now, I'd have negative 2 equals 1 minus 3, which does equal out. And here, if I have negative 2 equals negative 1 minus 1, we get negative 2 equals negative 2, and that also checks out. Okay? So we can double check our work. So even though I did it right, I had written my point wrong, so I can check myself. Okay? Why don't you try this next one on your own, making sure that we put this into slope-intercept form before we graph it. Okay? If I put this in slope-intercept form, I'm going to subtract the x over. So I'm going to have negative x plus 0. And I'm going to go ahead and graph that in blue. So I'm plotting at the origin and then going down 1 over 1. And again, I'm going to go in the opposite direction just to make sure I have a nice pretty line here. Okay. And again, that just kind of helps us keep straight what's going on when we are trying to see where they intersect. This one's already in slope-intercept form, so I'm just going to graph it. We have a positive 1 slope, and then my positive 1 y-intercept, and a negative 1, 2 for my slope. So I can see if I keep going down 1 over 2, that's not going to help me. So I'm going to go up 1 to the left 2, and then I can already see where I'm intersecting. Okay, I'm going to go ahead and draw my line this time. Okay. And we can clearly see that we're intersecting here at the point -2, 2. Okay, and again, just to make sure I'm correct this time, we can plug that in. So this would be -2 plus 2, which does in fact equal 0. And then if we do here, this would be 2 equals -1/2 times -2 plus 1. Well, -1/2 times 2 is +1, and 1 plus 1 does equal 2. So I know I drew my graph correctly in order to find my ordered pair. Okay, I hope this video finds you well. Have a wonderful day, and we'll talk to you later. Bye.